All right, we are back for more Shenzhen IO. Um, Give me a sec just to set up a few things here. Okay. So before we get into the new stuff, I did want to look back over a puzzle from last week. All right. So this is the haunted doll from last week. What do we have here? We have two different audio tracks that need to be played. This is a random number generator. And when we hit 1 or 2, we play these tracks on through to the speaker. So obviously there's a lot of duplication here, and it's gnarly. There's just too much code. And this is something I figured out after I ended the stream last week, but I thought of a way to de-duplicate some of this and salvage my initial design plan. So we'll go do that, clean this up properly. Let's just see how this runs first. And for what it's worth, I did learn a new thing by implementing it this way, right? So I have 3 things. Yeah, okay, my cost isn't great. And the lines of code double what it needs to be. But I did learn one thing from this, and it's that these wires here, I have 3 outputs connected. 3 different cables connected here to this output. And I learned that works if you want to send something on another cable. That works just fine as long as you zero out all the others first. So only one cable at any time is having a value greater than 0. Otherwise, what happens? I think it just becomes the highest value of any of them. Maybe. That in itself could be useful as a hack for something down the line. I don't know. But basically this design here. Okay. So here is Giggle and Cry, 2 different audio tracks. I had them saved in the ROM here. The only difference really here is that we're moving x0 to data rather than x2 to data. So we can hoist that line up. We can essentially just branch on this line on every loop. Instead of just branching once and then jumping into one of these 2 loops, we have a loop, and inside that loop there's always this branch. So how did this work? I'm just gonna delete cry over here. And we're just gonna call this whole loop play instead. And at the end, we jump back to play. So you don't necessarily move x0 to data. We're gonna choose. So we'll do a test equal, and RP0. So if RP0 is equal to 1, then we're gonna move x0. Otherwise you move x2. Is that right, X2? We can snip these address lines. We don't need them. X2 to data. And we test if the data is 0. Yada yada. Okay, we're missing a sleep here. So we move data to the output. And then we sleep for 1. And jump back to play. Now as for the done, when we're done, we set back to 50. So move P1, move 50 to P1, and sleep 1 second. And go back to the start. Now here we'll have another test, and if it's not equal to 1 or 2, let me see. 1 or 2, we do these things. Do you just do both tests in there? Hey, Sparkly Dark Matter, good to see ya. It's going alright. Your icon is not showing up on screen. That's a little weird. I'm just refactoring a circuit from last week where I used 3 chips, and you can do it on 1 chip. I realized this after the stream. I mean, I realized it during the stream. I just didn't have the energy to do it. It's late at night. So now we have a single play loop with a branch inside of it to choose which ROM to read from. It's unfortunate that we have to check that on each loop. We could check it only once if we didn't also have to do this check here. To check if the data is 0 and we have to end the loop. But I don't know, maybe there's a better way to handle that. Okay, so we're gonna test equal P0 as our random input. I guess we just check if it's 1 or 2. It seems like test equal P0, 2. And if neither of those is true, we jump to done. Jump to done. I guess I would do it. Label Odo. Something is a little bit off there. Did we read the wrong input? So expected 100, actual 100, fine. Expected 80, actual was 16, the second time through. Interesting. I was able to play the other one just right. Oh, no, hold on. This P0 is going to be changing as we sleep. This should be our data. And actually, this moving to data, let's put that in the accumulator. This moving to data can just be moving directly to the output, right? Move X0 to P1. And when we had a data check though, because we still need to check if it was 0. Can we read from P1 that we just wrote to? I'm not sure about that. Alright, we're still pressed for lines here, but we'll make it work. So first we're going to move P0 to accumulator, and we'll just test the accumulator. And this is me doing an OR. And if neither of those are true, we jump to done. Otherwise, we go into the play. Okay. That should fix that. Cool. One chip. My power usage is a bit high. Yeah, I'm executing statements I probably don't need to. So let's run a simulation here and pause with our profiler. Oh, this executes almost all the time. Even though there's this play loop here. It should be like the converse of, huh. Okay, let's take a look at that. Cool. Now once we get to playing one of these files, it should not be doing that header, it should just be jumping within the loop, right? Yeah. Okay, it's doing what I expect there. Jumping it done here as soon as we can. Otherwise, move the data P1. It'd be nice if we could just move X0 and X2 directly to P1. I wonder if I can do that. P1. P1, and can we do a test on data? Or on P1 instead of data? Like read the value to send it out that way? I'm not sure it works that way. Yeah, no, it doesn't work that way. I do just hate how often we check for the accumulator. But I'm not, with this design, this is kind of why I guess I skirted away from this design in the first place. Wasn't need to do that. So my previous design would have been, I guess, more energy efficient, even though it used more chips and more lines of code. I know I'm doing this. I'm making it compact for fun here. But yeah, this is a lot more compact. Okay, I won't dwell on this too long. How have you been? How's your weekend? I had a poker tournament yesterday. I placed 7th in a field of 30. I'll have to try it again and try to get first. I think first is within my reach for this one. Okay, nothing immediate jumps to mind for how to optimize that further, but these times aren't bad, yeah? Cool, I'll live with it. Okay, on to something new. The custom specifications, we'll save that for another time. Growing the company, please read. All. Over the last 2 weeks, I've conducted a thorough review of the company's product lines. We are showing some signs of improvement over last year, but we are still creating multiple products with no point, no goal, and no larger plans. Oh, she comes right out and says it, huh? I want everyone to think about how to focus on products that have the potential to truly change the world. Where are the devices that we feel proud of as a company? How can we earn respect? What future are we building towards? We must face these questions head on with all our efforts in order to have a chance at becoming the world's top electronics firm. My uncle named the company Longtang Rising Dragon for a reason. Okay, this you know what this is? Um, we are still creating multiple products with no point, no goal, and no larger plan. This is a direct response to the haunted doll. The haunted doll idea. Let's just sneak some audio chips into some dolls. And she was the one. Joe, are you serious right now? She's the one that hated this idea. And after the project was done, Joe wants to do more of it. And she's like, stop right now. I forbid you from doing anything further related to Ghost Electronics. And so she sends a passive aggressive company wide notice. Yeah. Okay. Aquaponics. Aquaponics maintenance robot. Okay. Surely many of you have heard of Sun Haoshan. His father was one of the first electronics entrepreneurs from this area, starting from when it was first designated a special economic zone. Now that he's inherited the family business, it would be no exaggeration to say he's the most powerful man in Shenzhen today. An opportunity has arisen to work with his conglomerate on a device that moves between stations in a line. Apparently, it's intended to service an automated aquaponics facility. It's a small start, but understand our relationship with him is absolute top priority. If he feels he can trust us, we'll continue to get bigger and better work from him. Okay. Shining the gens again. Yes, I am. How have you been? How's your week? Hmm. I optimized that doll from last week to fit on one chip, and Wu Lili here sent a company-wide email saying, we need to stop making pointless products. Still cold. Yeah, you're on the East Coast, right? Um, not as bad as last weekend, but we still have our snow and cold up here. The pointless products are fun. I I like Joe. I like Joe's. I guess he has a series of pointless projects. So that was the doll. What else? There were some ideas he came in like from a hangover. He wanted like a scorekeeping gadget. I don't know, but he's been at it. What's an aquaponics? A system for growing food that combines aquaculture and hydroponics. Look it up. This robot probably cleans or adds nutrients to the system as needed. Okay, we'll do something with a point for our fake employer. Um, okay, so radio RX non-blocking. Okay, typical radio input, non-blocking X bus. Motor is a simple output. connected to a bidirectional motor. Okay. Tool clean, tool feed are simple outputs connected to unknown tools. Okay. The maintenance robot begins in station 0. Pulsing motor to 100 and back to 50 will move it to the next station. Well, we have to keep track of the station number. Pulsing motor to 0 and back to 50 will move it to the previous station. Okay. Oh, so our baseline then for the motor is going to be 50, and we pulse it between 0 and 100 to move it in a direction. When a data packet is received over the radio, move to the destination station and activate the tools for the specified duration. Okay, so a data packet will be the station, clean, and feed time. Okay, let's see what that looks like. So to move to station 2, we pulse 100 twice, each for 1 second. And in this case, we clean for 2, we feed for 2. So we'll have 2 of those directly after each other following the pulses to move to that location. Okay. This will be interesting. So I think tool clean and tool feed can be a separate chip. Maybe we can do this in 2 chips. One might have to be big, but this one has 2 outputs, right? 2 basic outputs. And we send a signal here, I suppose, at the appropriate time. And this one, yeah, we will need a big chip because I want to reserve the accumulator for tracking our location. But it can still, okay, X2 over to the other chip that controls the other pulses, and P1 to our motor. Okay, so since we're saving accumulator for our position, we can move the radios into the data register and check on that. We won't really need any extra registers, will we? Yeah, I think that'll be fine. This might be something where we can do it just with this big chip. It's just that I want to use a gen plots command, so if we did that, we'd have to use a DX300. So that's still on the table for later, maybe. We'll see what we do. So first, we move our input to the data register. And we'll check if it's equal to 999. We'll label this start. So data is -999. And in that case, we'll sleep for 1 second and jump back to start. And maybe I'll be able to share those lines with the other bit of code, but we'll see. And then now we have to figure out the pulsing. So our data is going to be so our data is going to be our destination, our accumulator is going to be our current position, and it will either increment or decrement based on whether the difference then is positive or negative. And I recall in the manual, I had to pull up the manual here. I recall in the manual there's like a test compare that I haven't used yet, so I think that's what I'll be looking for. File, recent documents. Here we go. By the way, does anyone here like poker? I play poker weekly at some local games. And this weekend I was in a tournament. So if anyone's into that, I'll be happy to chat about it a bit. Test instructions, here we go. Compare. Okay, so compare if A is greater than B, we have a plus, otherwise we have a minus. And this test compare can just be in a loop. And if it's equal, it doesn't do anything to those. That leaves them both disabled. So we don't run the plus or the minus commands. Okay. But that means we still have to have a separate test equal command to jump our loop, right? Yeah, we would. One second here while I reorganize things. Okay, you know what? To tell you about poker, I'd have to tell you a story. So maybe we'll get into that over break. But I have earned a nickname at the local poker table. At the local poker tables. When I showed up to the tournament yesterday, I met a lot of people I hadn't seen before, and they already knew who I was, so my reputation precedes me. I am a legend. And I think it's also just fair to say that people retell stories, so that counts as legend status. Okay, so we have a loop. And we'll do this test compare TCP. Did I get that? Yeah, TCP left to right. So accumulator with data, where data is our destination. And if accumulator is greater than data, so in the plus case, we need to pulse left, which means pulse down to 0 and back to 50. Oh, So that would be what, gen 0 for 1 second. And the thing about the gen command, I think the gen command sets it back to 0. I need to check. This is not in the documentation, so I have to check the email. Where is it? Undocumented instruction? Gen P XY. It pulses 100, 0. Oh, we can't use gen here. Sleep X and sleep Y. It will always pulse back to 0. I mean, we could do like a sleep 0, but still, after that, we're just gonna have to move 50 into the output anyway. Okay. So back to the aquaponics. So move 0 2. Geez, maybe I have a separate chip for the motor because this will take a lot of lines of code. It's like 4 lines of code to pulse. That'll be 4 lines for either of them. Move 0 to 0 to P1. Sleep 1. Move 50 to P1, and then sleep for 1 second. And then at the end of all of this, we jump back to the loop. And then the minus case, yeah, the minus case is doing something else altogether. Okay, I'm not gonna try and cram that in. Let's do this the easy way first, and then we'll do it the cheap way. So this chip will just do the pulsing. So we're gonna sleep on X, waiting for X1 here. And yeah. And then now we can just branch on this based on whether it's positive or negative. Okay, so we'll just say like 1 and minus 1. So we'll best compare x1 with 0. And if it's positive, we do this stuff here. Otherwise, we have a negative case. I'm not doing that right. Okay. I want to have a mod for all those Zachtronics games that give you like read-line key bindings or like Vim-like key bindings or something like that. Okay, otherwise we move 100 to P1, sleep for 1 second, and move 50 to P1, sleep for 1 second. And this thing just handles a single pulse, no loops or anything. And then it sleeps and waits for the next one. In fact, this final sleep 1 kind of happens regardless, yeah? So we can remove that from there. Oh, the final move 50 also happens regardless. So move 0 and sleep 1. In fact, the only thing that's any different is the move 100 and move 0. Oh, you know what? This is less lines of code than I thought it was. We're still separating it. We can put it back together later. Okay, so after that, regardless, we sleep 1, move 50 to P1, and then sleep 1 again. And this last sleep 1, we don't even need to do we? We can just sleep X. So back to the start. There it is. That fits on the small chip. And instead we'll read from X0. Okay. And now in this case, I will probably just copy and paste this over here if I have enough room. In the positive case, we move 1 to X3. Otherwise, we move negative 1 to X3. And we don't just do that because we have to mess with the accumulator. So move 1 to X3, and we add 1. Right, if accumulator is greater than data, no. If accumulator is greater than data, it needs to move in a negative direction. Right. So we move -1 to x3, and then we sub 1. Okay, mildly confusing, easy to make a mistake there. And here we move 1 to x3, and then we add 1. Okay, and we'll jump back to the loop, but we need a condition. So we'll check test equal accumulator and data. If they are not equal, then we jump back to the start of the loop. Otherwise, we're done. We're done means we pass stuff off to this clean feed chip. And you know what? I think we can use the @ symbol here, because we'll only need to test that once, right? The test CP, because we're already doing a test for equality over here to break out of the loop. Oh no, that won't work, because when we do run this test for equality, it does flip these symbols over here. So yeah, that's unfortunate. We are in a space though. Maybe this one should keep track of our location. And should be a big ship. I mean, what else do we need to write? We basically need to send x0 over to this ship twice. And then, after all that, sleep. And actually, this thing here needs to sleep while this is acting. So it'll need to sleep while it hears back from that. I think if we don't have a blocking boundary between these two, it's probably better if we just move more of this over. So I'm gonna make a new big chip here. I'll basically combine these two here. This will only handle the big loop. So here, jump to start. Instead of going to the loop, it's just gonna pass data over to this chip. So it's gonna sleep on X. Waiting for X1. And move X1 to data. And then it has a loop. And instead of sending these signals, so TCP accumulator data, we're just going to do this over here. gotta delete the wire beneath it. Okay. So, when accumulator is greater than data, we move 0 to P1 to diminish it, right? We also sub 1. And when it's less than, we move 100 to P1, which increases it, and we add 1. And we sleep 1, move 50 to P1, sleep 1 again. Okay. And then after all that, well, we have to do our test. So test equal accumulator and data. And when they are not equal, we jump back to the loop. It's still the same code we had from earlier. Otherwise, we execute our done code, which is going to be to send the signal back on x1. So move null to x1. And then we go back to waiting. Cool. So one big chip just handles all the motor movements. And this one delegates there by just passing the data along. So we're going to move data to x3. And we're going to wait on x3. Move x3 to null because we don't actually need that value, we're just blocking. And when that's done, we move the other parts of the data packet. So we move x0 to P1. Oh, you know what? I think the code that's going to be here, we have 2 output pins. We can just do the pulsing here. So what happens? We would pulse to 100 on clean for the duration from the data packet. So we move 100. Just get rid of this chip. Okay, so we'll connect P1 over here. To clean. And P0 can be feed. So we'll move 100 to P1. We're gonna sleep an amount from the data packet. So sleep x0. And we're gonna move 0 to P1. Move 100 to P0, sleep x0 amount again, move 100 to P0, and then we just jump start right back to the start. We can probably add a sleep 1 here. There's no need to like test there again, right? In this case, we're always gonna sleep 1 after doing that. Wait, hold on. Move 100 to P1, move 0 to P1, move 100 to P0, and then we move 0 to P0. Cool. I think that will mostly do it. Got some issues here. Okay, baseline 50. We're missing that. And what's going on with the timing here? So we were late to pick up on this. So after we did all this pulsing and we did the clean, then somehow well, two separate issues. I'm gonna look at this issue first, where it starts at late. Where was that? Okay, so after this one here, we have a 0, and we are already at 0. Oh, okay, we have an edge case. So we can advance. Let's step through this. So on the left chip here, we move x0 to data, it's 0. So we don't need to move anywhere, right? And we move that data to x3. And it begins a loop by doing the test compare first. Yeah, and then it jumps straight to sleeping, the 150 whatever. Okay, so our test equal for accumulator data needs to happen like at the start. So I think our test equal, we should just jump loop no matter what, and our test equal should control breaking out of the loop, and we should do it at the start. Okay, test equal accumulator and data, and if they are equal, jump to done. Try that. Okay, much better, much better. Now we just need to initialize by moving 50 to our output here. I need to squeeze in one more line. I suppose we can get rid of that sleep line at the end. It'll still work just fine, yeah? Yeah, it still works fine. And at the start, you can have an at move 50 to P. Oh no, that happens on the motor. So it doesn't need to happen here. Need to squeeze in a line over here. It'd be nice if this test compare could actually help us conditionally jump. The problem is we kind of have like three branches, so we do have to have two tests. Because you have the positive and the minus, and this is stuff that happens in either case. And then there's the no case. Move x1 to data. Jump loop, move null to x1. Well, we can get rid of this move null to x1 line if we don't sleep on it. So here where we sleep x3 and then move x3 to null, we could just sleep based on the difference between accumulator. Oh. So we would, if I were to do that, then I'd also track the current location here in this accumulator. So when we get this data packet, when we move data to x3, we're also going to like add it or get subtract it. So like we moved 5, we take a 5 minus accumulator. And then our current location is 5, we get a 2. So we get like a 2 minus a 5, which is going to be -3. We just want the absolute value of the difference. Accumulator still needs to be updated properly to 2. Oh, right. So we save what we get from the data packet to the accumulator value, and we jump, and then we sleep the absolute value of the difference between the previous accumulator value and whatever we just put into the data register. I don't know if I want to do it that way. So we have these 2 lines. We need to remove these 2 lines. 2 lines isn't enough to do that, is it? Because this data will also have to move into the accumulator. That doesn't do it. Man, I'd need just 1 more line of code. I could start with like a... I could introduce another chip, volts 50 into that. I'm gonna do that just to... just to get this passing. Then we can look at the scoreboard. Okay, so this is gonna be move 50 to P1. And then sleep for 1 second. And then move 0 to P1 and let the other thing take over. That's only 1 second though. Like if it takes more than 1 second to get an actual signal, that won't work. And then this just permanently sleeps. Okay, that does it. That does it. It does fail for exactly that test case I mentioned here though. So that needs to be like an initialized line here. At 50, super annoying. Zero P1, move 100 to P1, add 1 to 1. Sleep 1, move 50. Can I use a gen command here? If I gen 50, no, the gen pulse only pulse to 100. Maybe I could take advantage of that here for just this line. Move 100 to P1. Nope. This line is a common line, the sleep one after it. So I'd also have to have a sleep line here. So we drop this line, but add a line over there in the plus case anyway. Let's see if we can... Well, just to get it to pass, we could. We didn't need this line here. I could add in another chip that basically just passes on the value, but first initializes P50. Right, like I could, just to make this pass, do that. And then, let's see. So at move 50 to P1. And then we're going to sleep on X0 and move X0 to P1. Instead of moving to P1, we're moving to X3. Yeah. X3. 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 Okay, that would fix our issue. I'm not happy about it. I may have liked Jane Street Admin FPGA. I think I would have liked it. I was wanting to do it, and I think, I know, work started up and whatnot. You know, I was thinking I'd finish Cynic Orbit faster, and then I'd be able to do the Advent of FPGA. Yeah, it was like the 16th. But I did want to do that. Yeesh, lines of code 31 compared to what, like people are doing this in 20? Um, my production cost is firmly average though. Well, not firmly average. There's two modes here. OCaml isn't that different. No, it's not that different from Scala. Yeah, I was thinking about doing that with hard camel. And honestly, OCaml has been on my like to mess around with list for a while now. I read OCaml on occasion, like it shows up in blog posts, or I'll see a streamer doing it. But I haven't messed with it properly. I think it's basically just an OCaml DSL for hardware, like a DSL hardware languages. Yeah, but OCaml is a good language for DSLs, right? So I imagine it's nice. Related, who was it that? Oh, I can't remember their name. Someone recommended the game MRHD. No, MHRD. Let me look that up. MHRD or MRHD, right? Microhard, which is basically just Nan to Tetris as a game. Like the first 6 chapters of Nan to Tetris as a game. And you use a hardware description language to build all the circuits to build eventually the full CPU architecture from Nan to Tetris. And since I'm wanting to, as a project, make like an anti-Tetris emulator and then do everything. So I want to build the emulator and then create the you know the VM, the compiler, everything from that layer up on my own stack. Now that I'm a lot more experienced, and do that again. And I was thinking maybe the microhard game would be like a good warm up refresher on the architecture. I can do that beforehand, and then for people that watch the stream here, they can be familiar with that architecture. But it's been a while since I've used any kind of hardware description language. Here it is. I did add it to my library. I think whether I played it on stream or not, I'd kind of like to be opinionated on it because I have read the book. I've done these projects before. I do want to get the updated second edition of the book though. Not that it'll necessarily be any more helpful. I think it's the same architecture exactly. But I like giving them money for that, and I want to see the updates. Okay, let's return to the email here. I received word that Mr. Sun was happy with the result of our work here. Clearly, it's part of a much larger project, but nobody I speak to will say anything more. Well, I mean, she wants more contracts there. Okay, do we... This is a little atrocious. I'll take one more look at it here. People are doing it in like 20 lines of code. So I'm missing something here. And I don't want to stare at it too long. I'll probably save this optimization for next week. But like it roughly makes sense, right? This handles the motor loop. And that can't really be much more concise, can it? And this delegates a little bit to the motor loop and then does pulses. Like 6 lines of code here is just pulsing. Yeah. I don't really see how that can be all that much more concise. Certainly limiting this chip would be great. I'll just run the simulation one more time here, see what my results were. Yeah, my power usage is fine, near optimal. If we drop that third chip, we would drop from 14 to 11 here. I think that's what the other mode is. Yeah, I just need to figure out some sort of trick to make it more concise. Second edition of it's called the Elements of Computing Systems. Let me look it up for you. Elements of Computing Systems. Here we go. This is one of my favorite computer science books, or it's one I'll recommend to people most often at any level. If you're already like an experienced programmer, it's still fun to do this whole thing. And if you're new, it's like very good for you to do this whole thing. But yeah, this is basically NAND to Tetris. Start from NAND gates, build a full-on compiler, and then a game on top of that. And like a running operating system, a VM, machine language. Oh my god, Midnight Simon. Hey, how are you? How was your stream? Welcome, welcome. We were just talking for a sec about Man to Tetris. I don't know if y'all have heard about it. Yeah. So I'll post this book again. The Elements of Computing System. That's where NAND to Tetris comes from, right? But this book walks you through doing you start with NAND gates. You build various circuits. You build like the higher order gates. You build memory. You build an ALU. You build on a full CPU that runs machine code instructions. You build an assembler for that machine code, and then you implement like a stack-based virtual machine that on top of that assembly language. And then you build like a compiler for a Jack for like a Java-like ish object-oriented language that runs on that VM. Then you build like some operating system utilities, and then once you have all of that, you can build um, Tetris or whatever game you want on an architecture that you understand literally from the gates all the way up. Uh, so a good experience for anyone to have. Whether you're new, it's accessible if you're new. And if you're experienced, it's still a lot of fun. So you're just doing some leak code and chilling. Cool, cool. I like your chill leak code streams. Um, you know what I miss is the binarysearch.io. I'm so sad that that died. That's when I started watching you, was when you were doing a lot of the binary search. I'm kind of pissed that they just like cut it off without any warning or whatever, because I had a lot of code saved in there. I started like writing up a lot of solutions to problems, and I lost all my solutions, all my code that I had in there. Super annoying. If they were gonna go belly up, they could at least have told us, hey, get your data. Yeah. What kind of glasses are these? These are just, honestly, I picked these up at, uh, I don't know. It's like an impulse buy at like a touristy whatever. They were just selling all those knickknacks or whatever. But I liked them. I like wearing them. I mean, they look good, but they make everything else look good too. Um, it gives everything a nice, like, warm glow. To have rose tinted glasses. Golden hour lasts 3 extra hours. And then when I'm here streaming under these lights, it saves my eyes. But yeah, just cheap old tinted glasses. Um, anyway, what we're actually doing tonight is playing some Shenzhen IO, where we have a job as doing electronics and writing assembly, building circuits to build all these random little devices. Really fun. I recommend it. They get really into the role play, right? So they give you a manual. You have to read this manual, and this manual actually starts off. Well, it starts off with instructions for putting this in a binder. I haven't put this in a binder yet, which is kind of a. I think it's lame of me. I should have a physical binder of this manual. Um, but it starts off with like the emails that you're role playing, looking for a job. You couldn't find a job in the States, but some recruiter hooks you up with an electronics firm in Shenzhen, and then it even has like a visa application form. I mean, it's obvious I'm not gonna fill this out on stream, but yeah, it even has my residence. So I now live at 1210 Baonan Road, apartment 2109. 2109. That's like a 21st floor. Um, yeah, it's fun to lean into it a bit. And as part of that, we have like an email system. So I have to check through that. We even get spam apparently. So incredible opportunity, land rich in rare earths. We are contacting you about an incredible once in a lifetime opportunity to own land rich in rare earth metals in the western region of China. What are rare earths? Rare earth metals power the world's electronics, phones, engines, motors. It's fair to say the world would not run without them, but the world's supply of rare earth metals is drying up. Mining companies can't refine them fast enough to meet demand, and now the mining firms are looking to expand. Now is the time to own this land before the mining firms find it. Or you could buy a blind in Africa, I guess. But I know they send me spam emails and I don't have a way to respond to them, so I can't actually engage in this once in a lifetime chance to buy land. So on with the next one. Oh, I want to share some Spoker stories tonight in a bit. So I'm curious if anyone here likes playing poker. So a remote kill switch. I would like to have a remote kill switch for autonomous systems. This is in case of failure of the autonomous system. Of course, such a switch should not be needed if we were always if we always designed the systems correctly. We should make this. I'll create the transmitter and you will create the receiver. Okay. Well, welcome back, Suno. Okay, we'll take a look at one more then. So we have a radio, a non-blocking X-bus input, connect to radio receiver, okay. Power 0, power 1, and power 2 are simple outputs connected to higher power switch. Okay, yeah. When a data packet is received over the radio, read it and execute the corresponding command in the following table. So for -1, we keep alive and do nothing. For 0, we power off the next value that comes in. And for 1, we power on the next value that comes in. Where by power off and on, we mean move 100 or move 0. Oh yeah, the card counting stories at casinos. Yeah, I love hearing it anytime like a mathematician takes advantage of gambling. Like every now and then there are like lottery scratch games or something that have flaws in them and like a mathematician will figure it out. Actually, what do you know about the group, the MIT group that was doing the blackjack card counting? Because so here's the thing with blackjack. If you play blackjack perfectly, no card counting, then the game is 49.5% in your favor. It's basically coin flips that the casino just wins barely a thin slice on. If you include card counting, it becomes 50.5%. So it becomes barely in your favor. So even with perfect play and perfect card counting, which if they notice your card counting, then they'll kick you out. Then you barely have any edge, and you have to sit there for a long time for that to actually make anything of it. So what the MIT group did was they split up the card counting from the people who'd actually make the money, right? So you'd have people sitting there doing the card counting, and they'd signal to their buddies, and they would basically go min max when that edge existed. So someone would show up, they'd get the signal from someone else, and this is when they like start betting, huge amounts of money on those just tiny edges at the end. So at scale with a group, you can apparently do better. But yeah, on your own, not very worth it, but be kind of cool to learn, right? Tell people, hey, I know how to card count. All right, so probably I'll do this on this splitter here. So if I send a 100 into here, it will light up P2, P1. It'll just light up P2. If I send 10, it'll light up P1. If I send 1, it's binary. It's this game pretends there's no binary. It's just like the tens digits. So 111 would light up all 3 of these. So probably I will make things work that way. Stephen Bridges has a great series on that. Okay, yeah, I'll look that up. I've wanted to watch 22, the movie about that, but I hear it's actually terrible. Hollywood screwed that up. Poker is fun to spectate. Even though I'm just sitting at a poker table watching, it doesn't even have to be a good player. I just like watching people play poker. There's like so much going on, like whether they're aware or not. Um, let's look at the verification tab here and see what the data packets actually look like. So we get 1, 1. The first one, okay, that means power on. Power on. This one, the middle light. 1, 2 means power on the 2 light. Okay, and eventually we have like 1, 0, power on the 0 light. Fair enough. Yeah, card counting is one of those things where like it'd be fun to do, but it'd be cool to say, but it doesn't sound like a lot of fun to actually do. Maybe, I don't know, maybe it's satisfying. But also, you know, all those memory champions that are like memorizing whole decks of cards. Like they have competitions where like they'll give you like deck after deck of cards, and you're sitting there and memorizing all these decks. Like those people aren't superhuman. Like you can train the memory techniques and get there. I read a really great book. What's it called? Moonwalking with Einstein. And this was about a journalist. So this journalist was covering the American Memory Championships. You know, these people memorizing all sorts of weird things. And you know, like he is wowed by all these people. Right? Like anytime it's publicized, it's a big wow for everyone. And while he was there, he met these European guys, and they were not impressed at all. And they told him, "Hey, this isn't actually that good. I bet we could train you, and you could easily beat these guys." And then that's what he did. For the next year, he trained with these European memory champions who were there visiting. And a year later, he came back to that same American memory championship and he won it. So a year of training was good enough to beat the American memory champions. And this guy had like no special memory or anything. He just like training and diligence. And that book, Moonwalking with Einstein. Yeah. Oh, you read that? Yeah. It was. It's a good book. It's a good book. Um, I like this genre of like journalists really like getting into something and then writing about their experience. What else can I think of in that category? There's one about poker. The Biggest Bluff by Maria Konnikova. She was like a psychology PhD doing like judgment decision making. She trained with a poker pro and then won some big tournaments after that. Leveraged all her like psychology knowledge to well, she still had to learn poker, and it was still like a ride, but she's able to be one of the best, like top 1% easily. Although, like top 1% in poker, like if you're making money at all, you're already in the top 10%. It is so skewed. Um, Born to Run is kind of similar vein. Like a sports journalist got into running and then started running ultra marathons after meeting like all these big runners. Yeah, the Memory Palace. Oh, everyone's got the mind's eye. That's like our most like the biggest system in our brain is like our visual system. But yeah, I like books like that. And I am super sidetracked from the actual thing here. Um, let's actually do this. So we have our X bus. Based on if you get 1, 2, or 0, we're going to activate just one of those. So what I think I'm going to do here is I'm going to use the accumulator to save the current state. And we can modify the accumulator. There is... Oh, no. Edges in poker are good. I want to hear about people making money. And I like playing with more of a challenge in poker. It's fun to win and take money, but it's also fun to like have the arms race with someone, you know? Like when you play with the same people over and over again and learn how they play and just start countering them specifically because you play with them so much. Okay, there's a command I'm looking for here. Digit and digit set. DST. Set the digit of... Okay, so DST 0. So it sets like the 0 digit to some value. Right, so when I get an incoming command, I can set that digit to 1 if it's a 1 command to like turn on, and otherwise 0 if it's in fact... Let me see. First off, we're gonna read from the radio. So we're gonna move x0 over to theta. We're gonna check if it's -999. And in that case, actually, I think it's the same with the -1 case. So we're gonna test instead that it's not negative. So test greater than -1. If it fails that test, data -1. If it fails that test, we're just going to jump back to the start. Sleep 1, jump to start. Ari, welcome. Just hanging out and writing some assembly. Okay. Otherwise, then we have either a 1 or a 0. In case of 1, we're going to turn a digit on. I think actually we don't even need to branch on that. We don't need to branch on if it's 1 or 0. What we could do is digit set, and the digit we set is going to be given by the second value in the data packet. So we'll read from the X bus, x0 to data, right? I think that's it. That might be this whole thing. Oh, we've got something wrong here. I think we're forgetting to sleep. There we go. Let's give that a shot. Nope, we're missing some. Oh wait. So after we have after we set the value in our accumulator, we should actually move it out on x3. So after we've done all this, we're gonna move the accumulator out to x3, and then we sleep. Cool. Hey. Oh, hold up. Oh, I didn't realize we could toggle breakpoints. That's so helpful. But also, the actual issue here is that all these should be off. So I'm missing something in the specification. Turn off all power outputs when 5 or more time units have elapsed without receiving a data packet. Ay, Nicole. Okay, that's annoying. Okay. Here I thought I was just going to be able to condense this onto one small chip. So the accumulator will need to be reset to 0 after 5 seconds. And here's the thing, where I'm going to keep track of the time. Because if the accumulator is already keeping track of the state of this here, I need another chip. That's unfortunate. Well, maybe we can have 2 small chips. This chip can just track time, I suppose. And in the case where it's -1 or -999, we would increment this over here. So we could connect this with a bus, x1 to x0. We're going to sleep on x0. And I suppose we could add a second. So test equal on x0. If x0 is 1, then we just add 1 to our accumulator. Right, then on every loop we test if our accumulator has hit 5. Okay, test equal accumulator to 5, and if that's the case, then we need to send the signal back up here. Oh, I think this is gonna have to be like a bidirectional communication each time. Okay, so in this case, when an accumulator hits 5, you move 0 back into the accumulator. And then we got to move some signal. Let's say we'll move 1 over x0. Alright. And then otherwise, if this wasn't a 1 here, then we set it back to 0. Move 0 into our accumulator. We reset our timer. Reset our timer. Okay, yeah, in both these cases we reset our timer. Probably I want to combine those later on. And then we sleep. Oh, we don't need to sleep because we're just sleeping on x0. Move 0 into our accumulator, and then we have to jump back to the start. Jump to start. We don't need to do this test for equality, right? I think technically this line here is optional. It just saves us time. But every time we respond to an SLX, before we jump back to the start, we do need to send a signal back. And that signal, move 1 over x0. So in the other case here, in the minus case, we move 0 over x0. And I suppose we'd have to have that here too. So I'm just going to remove this jump line. It's less efficient, but it should work. Right, so what this is doing, we wait for a signal. If it's 1, we add 1, otherwise we reset. Right, and every loop, we're checking if we're at 5. If we're at 5, then we send a signal 1 over, otherwise we send a signal 0 over. Okay. So we do all this digit setting stuff. Now in this case here, where we're actually setting digits, this is a 0, right? We only send a 1 over if we're incrementing the timer. So we're gonna move 0 over x1, and then we have to sleep on x1, and we know the result is not gonna matter. So we are going to move x1 over to null. Right. Because we don't care. Yeah, because we know we're not resetting. What we're looking for is a signal that tells us to reset. Let me just label that here. Our 1 signal will mean reset, or like power off, power everything off. Okay, so in our negative case, we do still have to send a signal over. We'll sleep 1 at the end of that. So we're going to move 1 over to x1. So this is our signal to increment. And we're going to sleep, waiting for x1. And okay, now we have to branch depending on what x1 is, right? If x1 is 1, we have to have some process that zeroes that all out. That's equal x1 0. And now we get into like a nested conditional case. So I'll want to jump over to another block of code that handles that. Okay, I need more lines of code. So I think I'm gonna have to move this bit over. To a new chip. And then maybe I could like combine these two. I don't know. Yeah, actually it'd be nice to combine this counter with the main loop, because they're so like interlocked, where we're having this x bus back and forth, whereas this bit here doesn't need to communicate back and forth. So this is the one that should be on a separate chip. So we'll do just that. So just this beautiful bit of code I wrote from earlier. Move x. Oh, but I want the data register. Yeah, I want the data register. So it has to be a big chip. even though there's not much code that's actually going on it. I wonder if there's a workaround there. Instead of the data register, digit set x0 to... Oh, you know, we could just do x0 to x0. We could just send them in like a different order, right? But this thing needs to know. This thing needs to have a signal to reset everything altogether. Right? Whatever's connected to this needs to have that signal. So we move accumulator to x1 instead of x3. We don't need this line anymore, or this line. Zero data. Yeah, a lot of this code that's inflating this is actually just coordination code with this other chip. So if we can just squeeze everything else out. I think we don't need to have a data register here. The only reason we needed to have a data register here was that the order this came in, right? So this data is going to be, it's first in, but it's like the second argument here. So this can do the job of reversing that by using its own data register. So this can be a smart chip. We should set x0 to and x0, and we're gonna move ACK into x1. And honestly, this can sleep x on x0. But now, this also does need to have a signal. That's time to reset. So first we'll test equal x0. This is our reset signal. So if it is -1, then we do something different altogether, and that is move 0 over to accumulator. Otherwise, we set just a single digit based on the next two values. Right, we do the digit set on our thing, and then we move our accumulator out to x1. And we sleep a second. We need to sleep a second. I don't think we even need to do that. We just sleep for the x0 input. Okay. So there's that. I think I'm gonna need a lot more room here, so I'm gonna squeeze this over. Okay. Now this main control chip here can do a little bit less work. So we still start by moving x0 to data and branching on that. Yada yada. Now we don't need to move this stuff over to another chip because our accumulator here is going to track our time elapsed. But instead of this digit set, x0 and data. Instead of this digit set here, what we're going to do is move from our input, our x0, directly to x3, and then we're going to move data over to x3. And this is all the, I'll get this a label just to make the code a little bit cleaner. This is our toggle. Yeah, it's like a toggle of some sort, right? And the signal that we're actually doing it is anything that's not -1. So we're just gonna move 0 over x3. And otherwise it'll be ignored, right? Then we move x3 over to x3, we move data over to x3. Great. And then we have like our kill all command. And in that case, we move -1 over to x3. Okay, so here we move x0 over to data if it is if it's 0 or 1, then we can set our timer back to 0. So move 0 to back. That's this code from here. Otherwise, we add 1. We add 1, and then we're gonna jump to like our test. And in our test case, we test equal accumulator to 5. And in that case, we are doing our reset. So move x1, move 0 into our accumulator. And then we go to the kill. We send the kill command over. We fall right into that. And after killing, we sleep 1 and jump back to the start. All right, so add 1, we jump to the test. Otherwise, we jump into our toggling code, which sends the appropriate signals over here. And when we're done with our toggling code, we want to like jump to our end, which is our sleep 1, I guess. Okay, that should roughly do it. Cannot read a pin twice. No, my whole design was built on that. What? Okay, that's really annoying. Cannot read a pin twice. I mean, I can do a hacky workaround around that. Okay, I've got an idea here. We can do x0, x0. So instead of that line, x0, x0, we're gonna move x0 over to p0. No. Okay, I'm just gonna do the minimum to make this work. We might have to refactor later. We're just gonna move it onto another chip. That chip is just gonna feed it back to us on a different pin. Identical. Okay. So we're gonna move x0 over to p0. And then we're gonna do dst p0 or p1 and x0. Okay, and all this chip's ever gonna do is move p0 to p1 and sleep. And the whole thing's broken. I don't think it's as broken as it looks. And this is wild. Like this started off with like a 5-line of code thing. Like basically this. I was like, I thought I was done. I'm doing all this other stuff just to basically hack on that timer onto this. When I should have designed up the timer from the start. Okay, so what's going on here? This chip here should be keeping track, and its accumulator should be keeping track of the elapsed time. So it is not even doing that. So move 0 to accumulator, add 1. That add 1 should be executing when it's like -1 or -999. So let's step through that line by line and see what's not happening. Okay, so here we have -999 come in, right? It's in the data register, so we add 1 to our accumulator. Great. And then we jump to the test. We're not at 5 seconds yet. Oh, whoops. This move 0 should be gated. This kill can also be gated under that plus. Okay. Let's give that a shot. And what happened here? It looks like we turned on 2 different inputs, or we turned on the wrong input. Oh. Did we send things in the wrong order? So what's going on here? Let's jump. Okay, so this is when the 1-1 comes in. I need to be able to see the cables here, so I'm just gonna make that longer. -1 comes in. Okay. So now we have a 1 coming in on this X bus, right? So we step through that. And we're gonna pass this test, which means our accumulator that our timer can go back to 0. And then we're gonna toggle appropriately. So we're gonna move 0 to x3 to tell this chip that we are doing a normal toggle wire command rather than a full reset, right? So we send that over. It tests that it's -1. It's not -1. Which means we move x0 to p0. where x0 is the one from here, the second one, right? The second one being the which one to toggle. The first one was like on or off. Right, so that goes in, and we send that for a little loop. Then we do this. Oh, it's late because of this here. The STP1. Right. I think I need to do this on an X bus instead. This is where our issue is. We need to actually wait for that thing to propagate. So we'll make that an x0 and out on x1. And this chip we need to replace with one that has 4 X buses. Okay, so x1 is going to be renamed to x2, I suppose. Or you know what? It can be x3. Yeah. The output is now x3 and connects directly to that chip. Great. And instead of moving x0 over p0, we're going to move it over move x0 over to x1 to the other card. And then we do this DST, we're going to do x2 and x0. So now this chip is going to sleep on x0 and then move x0 to x1. And before we do this digit set command, we need to sleep on x2. Okay. Okay, that was working. It looks like so we have an issue once the second command comes in. Our accumulator, this accumulator here, should actually be at 0, 1, 0 right now. So it looks like once we did that, it became 1, 0, 0 instead of 1, 1, 0. Right? So we did correctly set that digit, but at some point, I think maybe we zeroed out the whole thing. This is 1, 2, 3, 4, 5. I think we might have like an off by 1 on our timer here. I'm gonna make it 6 instead. Okay. What happens here? We have a long wait. Oh, I see what's going on. The negative ones matter. Okay. The negative ones matter, so the reset only happens without receiving a data packet altogether. So the negative 1 on its own counts as a data packet. But once you get negative 999s many times in a row, okay, so only negative 999 will increment our timer. Okay, so let's add that here, test equal x0 to -999. And in that case, we're going to add 1 and jump to the test. Otherwise, we're gonna set the timer back to 0. So move 0 into our accumulator. And this doesn't need, well, that should still be there. Oh, we were redoing this previously. Otherwise, we move 0 back into accumulator and we do a normal thing. Move 0 over x3. Move all the information over to x3. Yeah, that looks fine. Not quite. Okay, we get here. -9. Oh, wait, we need to handle the -1 case now. So otherwise, we test if it's 1, if it's -1. If so, we jump to end. And we move 0 to, we still move 0 to the accumulator. But -1 should never go here. Well, oh, our -1 case. We can still move x0. Test equal, well, here's an issue here, that this should be on data, not -999. And we're going to test our data is equal to 0, or equal to -1. And in that case, we jump to the end. Basically, this whole toggle thing should be gated. Test greater than, test our data is greater than 0. And in that case, we can do this toggle stuff. Otherwise, we jump to the end. This should be test greater than -1. We're not turning them back off. Test greater than -1. Okay, it's, oh, wait. We're back to the start. This is what I was doing in like 5 lines of code. Our kill switch is not working again. Okay, so let's watch what's happening with the accumulator here. 1, it's back to 0 because we're hitting -1s. That's fine. That's supposed to happen. But once we start hitting lots of -9s in a row, so here we hit a -1, and then we have 0, 1, 2, 3, 4, 5. Now at this point, so I see we have another off by 1, but let's at least check the logic. So once we're at 5, we didn't add 1, we jump to the test, and we test that we're equal to 6. And in this case, we move 0 into the accumulator, right? We reset that, that's fine. And we move -1 over to x3, and it's going to do the reset maneuver. Right, so here we see a -1, which means we can move at 0 into our accumulator, zero that out. And after we zero it out, we actually have to put it out. So move 0 into the accumulator, and then move accumulator out into x3. Okay, and I see this line is duplicated, so we can probably just move the negative sign from there, but let's just make sure that works. Okay, cool. We just fix our off by 1, and we're golden. Take out that negative, and we can just take out this line. We always move the accumulator into x3. Okay, hey, it's working. And the only reason all this is happening is we just don't have enough registers. So I'm using this accumulator to count. Okay, hey, that's not terrible. It's a little bit more expensive than it needs to be. Primarily because of this useless chip here. Thank you, thank you. Move this into the accumulator. Yeah, so this accumulator is used to track the state of this, which maybe that's misguided. I like it. I still like it. It's clean. It allows me to use the digit set command, and I don't want to let that go. And then this accumulator is used to store the clock, and then this has to have the data register. Just because we're reading from this radio X bus input. And for those -989s, you have to cache it. So it has to have the data register for cache. So you have to do this in 3 registers minimum if we're doing my style design. And this whole chip here, super annoying that I can't just take it from... You know what I could do instead? So move x0 to x1. I have another idea. Instead of... So I wrote all of this because I want to write dst x0 x0. I can just do x0 x1 and send the second one over a different X bus. That's an immediate improvement. So let's just get rid of this chip here. Okay. So move x2 over x1, it comes back. x0 to x1 comes back over x2, yada yada. So our first DST is just going to be x0. Our second one's going to come from x1, and we don't need to do this sleeping thing or moving to another chip. Because over in here, we're going to move x0 over x3, and then we're going to move data over x2 instead. Not sleeping blocked on read. Okay, right. So we move x0 over x3. We need to sleep on x0 and on x1. But then now this is going to be, oh, we have like a blocking issue here, don't we? Yeah, we have to use that value from the X bus. We actually have to, and we don't have a data register. Well, I mean, I guess they both have to be big chips. Okay, I'm gonna undo that. I thought I was being clever. One big chip is cheaper than two small chips. So like I can do that optimization. Yeah, we can do that optimization. And then we can save whatever other optimizations for next week. So I think we want to preserve. Okay, so instead of moving x0 over to x1, we're just gonna move it over to data. And then we're gonna DST on data and x0. And hopefully everything else can be like similar. So this is using x0 and x3. Okay. That is at least cheaper. It's just it just takes so many registers, and I need to figure out how to do it with fewer registers. But my lines of code is firmly average. My power usage is firmly average. My pricing just $1. When you want extra, cool. I'll live with that. I'm okay with being average. Sweet. Can't be too careful when you make robots. Am I right or am I right? I'm learning some more casual style English from Joe. Oh, geez. You scared me for a second there, Jay. Okay. Well, that worked out. Um, so I owe you poker stories. So, one second here, sorry. I started playing local games here. So I live in Maine, and Maine only has like one official like casino poker card room. And it's like barely ever open. So if you want to play poker in Maine, you play at a bunch of like local home games all over rural Maine. There's like a network of it. You get in contact with the right person, and then eventually like there's a whole network of it, and you just kind of figure that out by word of mouth. Um, so I started playing in local games in like September of last year, August of last year. So I've been doing this for about 3-4 months, and the games are actually really nice. I'm having I'm I played a bunch of like home games with family or like in college. I used to organize a game when I lived in San Francisco, and I played at a bunch of casinos. But the games in rural Maine are actually a lot easier than those. So I got really excited, um, because now I can actually just kind of relax and have a little bit more fun. And I show up to one of these games. Yeah, flex a little. Um, I mean, I'm not like a great poker player, but I've read books. Um, I track my bankroll. I am a winning poker player. And like I've done my homework. Like I do my studying, and that's enough to put you ahead of the curve. But like still, you go to the casinos and you find like a lot of other poker nerds. Especially like the bigger the casino, like the more poker nerds you'll find, and if you run into that, they can give you a hard time if you run into them. I remember running through a few of those in like Austin, Texas, and just being like really impressed at how they could just um, maneuver away from me and like always stay ahead. But that's not what's happening here at these local games. So I show up to my first game and I get dealt seven deuce 5 times that night. For those who don't know, seven deuce is like the worst hand in poker. They're low numbers and they're not even connected enough to make a straight. You can't even get a straight out of it. So it's depending on the statistics, depending on like your metric, it is the worst hand in poker. But it's the one that has a reputation for being the worst hand in poker. So I get dealt this 5 times, which in the course of like a 5 hour night, that's already impressive enough. There's like less than 1% chance of that happening. Like usually you get that once per night, if at all, right? And each time I got it, I played it, and I played it as a bluff. Um, and when you bluff in poker, you don't have to show the table, but every time I won with it, I showed the table. This happened over and over again. One hand, I bluffed someone off of like a $200 with it. Um, and yeah, it was impressive enough that I had 7-2 5 times, but then I showed it as a bluff 5 times on my very first night showing up to, hello, my name's Stuart. I bluffed 7-2 a lot of time. Um, so that was their introduction to me. That was not something I normally did. Like, yeah, I did like on occasion. I was feeling smarmy when I showed up here. I was feeling cute. Um, so the next time I show up, and already I have a nickname, and one of them greets me as 7-2 Stew, and um, that stuck around. And I've kept my initial thought to doing this was like, okay, I'll just do that as like I play pretty tight, so I wanted to do that as like, okay, this will be my only bluff. Um, and I'll show it to them so that they think like I'm a big bluffer or something, and then I'll just play my normal tight game. Um, but it's kept happening, so I do this like once per night if I can, and I know I think like some like god of mischief has taken has been like a muse and has decided to like grant me their blessing because it keeps happening at like really opportune moments. So um, at this point, the community like waits for it to happen. When I showed up to the tournament yesterday, there were a lot of people I hadn't met before. They already knew me as 7-2 Sue, and on the whiteboard where they list everyone's names and seats and whatnot, and that's what my name was down as. Um, and I've had like several really big bluffs with 7-2, and I've had several times where people called down huge hands. It happened just last night actually. Someone called me. I had like ace 10. 10 was the highest card on the board, so like top pair, top kicker. Someone called me down to jack 10, um, and, and like blew up the pot to like $200 or something because he thought I might have 7-2 and that he'd win the 7-2 jackpot. Because he said it looked exactly like what I do when I'm bluffing 7-2, which is the point. uh, and there was one night. Okay, there are several nights. I have way too many stories about like my 7-2 antics. But there's one night that I really like telling about. Um, there was a player. So there was a hand where there was like a slight misdeal and whatever. The dealer fixed it. I can't even remember how exactly the dealer fixed it or whatever, but there are like two standard ways to fix that issue as far as like dealing the next card, and whatever way you fix it doesn't really matter. Like the cards are shuffled. If it's random, it's still random. But like players get suspicious about the ordering of the cards. Like when something happens and like a card is shown ahead of time or something and burned, they want the rest of the cards to still be like in the same order it would have been or something like that. So there's like a standard way to fix it. I mean, there's a couple standard ways to fix it. And the dealer chose one. And it's kind of like the standard way they do it here. Um, and there is a player. I'm going to call him. I'll just call him John. Uh, so John, I remember when I was watching this hand, like he had a really, really horrible river bet. That you know, like he lost a bunch of money on this hand. Um, but some player pointed out that hey, why are you doing it? Why are you facing it this way? And like got into an argument with the dealer about like the proper way to fix it or whatever. And then this player got it in his head that it was a dealer's fault that it was a dealer's fault that he ended up like going big on the river card because it would have been different. It would have been a different turn card if he had if the dealer had like dealt what was originally going to be there or whatever. Right. So now this player starts arguing with the dealer and like berating him because he had because like the dealer had cost him money or whatever. And here's the thing, like he didn't have a reason to be upset, right? Because like the turn card changed, he still shouldn't have been betting, and he shouldn't have been calling on like it. Whatever the board was is scary. There was like it was a paired board. I think there were like paired aces. There's like a flush possible. It's like a really scary board. Like a lot of things could be there. And all he had was like three of a kind, fives. I think it was fives. He had no business playing there. Um, but he gets this in the head. There's a scapegoat, and he starts bullying the dealer. And now here's the thing: the floor, um, the the host of the game was the one who actually had a reason to be upset because he would have had the top flush, and then the aces came in with like a full house. Um, so like when he gets tilted, he'll like go outside and then take a little break. So he leaves after that hand just to like go take a break and reset himself because that's upsetting to see yourself lose that much money. And while he's gone, this player John and the dealer are like arguing. And like players, you know, like I chime in, some others chime in. I point out like his river bet was horrible regardless, um, and that's not working. So we kind of let them handle it. And this player bullies the dealer into giving him his tips. So the dealer's tips, just like the end of the argument, the dealer says, "Okay, fine, here, take my tips," and he just gives it to the player. He shouldn't have done that. The host didn't like that. When he came back, he said that's not how that should happen or whatever. Yeah, yeah, fucking John. Anyway, we have you know, like the table's tense after like that kind of conflict. That's not normally how the game runs. And just after this, I get dealt 7-2, and I decide to go with it. So there's a hand. There are like three people in this hand betting pre-flop, and two of them are the players like that had caused the issue. So the one that was arguing with the dealer at first and gave John the idea, and then John himself was in there. So both of them were in there. So I decided, okay, well I'm gonna squeeze on them. So I do a big bet, uh, big enough to like squeeze out, just get one of them. And John decides to stay in. The others, the others all leave, and it's just the two of us on the flop. Um, and I can't remember what the board was, but it was in my favor to like continue bluffing. So we escalated. I think we escalated on the flop, and then on the turn I bet big enough to fold him out, and then I show 7-2 to the table. And it was like the perfect is perfect timing because John here is a big villain that like no one was liking, and everyone needed like some comic relief. So I get a big bluff. The whole table makes a racket of it. They'll do that for me now whenever I get a big one off. Even the guys who've been hit by it now just cheer me on instead. So it's turned out for the good. Um, but I wasn't doing this all in good fun that night. So after this, uh, I make it my mission just to make John's life hell. And every time he would get into a hand, I'd be in there raising with him. I'd be right in there with him. So I'd like raise on him when he like overextends, and just like make it really like give him a lot of hard decisions. Um, and I would even like get in on, so like maybe I didn't have the best hand, but someone else. So the host kind of got in on this with me, where like we'd kind of tag team and we'd figure out like who had the better hand and leave the person with the better hand to deal with John. Uh so like even in hands where like like it wasn't good for me. Like if he was in a bad position, I'd raise it just to make the stakes tougher on his hand, and then I'd leave, and I'd like the host or like someone else take care of it. My camera froze. Okay, let me fix that real quick. Um, yeah, and then like I'd play against the host. I'd play against the other players, and it'd be like a normal hand, and then John would get in a hand, and everything would just be escalated every time. So I think I busted him out. Like I got him all in like two more times, and he just kept buying back in. So I was like, I'm gonna bust him out, and then I'm gonna leave because I'm just here to bust him out. And he kept buying back in. Um, and here's the thing: every time I'd bust him out, I would tip the dealer like 25, $50. I'd make a point of like tipping the dealer big, and by the end of the night, I'd tip the dealer like $300. So I got the dealer all his tips back and more. Oh yeah, we were having a great time. Like we were bonding. I think that like that was a moment when like I was sort of like cemented in with the group. Like the host liked me, the owner of the venue liked me, and we all had like this common enemy. Yeah, by the end, John owns a like a pizza shop. By the end, he was paying for his buy-ins and like pizza credits. He's like, "Hey, I'll give you $100 for pizza at my shop or whatever," and you buy back in. So he lost a lot of money that night. Uh, the dealer made money, and yeah, it was a good time. But I definitely have a reputation. I have all these stories written down somewhere. Like I do record what happens at a game. I'll do like all my analysis afterwards. I'll track my bankroll and then I'll write down all my hands. So there are a lot more stories in there somewhere. But that's the one I like because it felt good to like I don't know, it's cathartic to like target someone and have it work. This is the thing about poker is I mean it's compelling enough from just like a theory point of view, right? Like there's math. The math is kind of the easy part. This is like probability and risk. But you have to like kind of stake your calculations on actual money, and then on top of that, there's your own like emotional management and not tilting and getting angry or getting like scared or whatnot. Like you have to be keep track of where you are. You have to keep track of where all the other players are. Um, and like how they're feeling. Like poker takes a lot of empathy. Sympathy can be selective, but like empathy is you need like weaponized empathy for poker. Um, so there's that like whole emotional angle, and then there's the whole like psychological angle too. So I like chess is just all calculation. There's no like hidden information. Um, but poker has it has a randomness, um, which brings in like the probability math, and it has the hidden information and like the psychology of working with other players and like all the emotional management. So like, and then on top of that, you bring in like a social dynamic with people that know each other, or like you have a player like John being an asshole, um, and it's just a very kind of dynamic arena. It's like life in miniature. You can do the right things and still get a bad result. But it's like a sandbox. You're allowed to kind of play with social dynamics in a way that wouldn't be acceptable in real life. So yeah, that's what I like about it. I've been thinking one day it'd be cool to organize a poker group online, and I don't know, maybe I'll do that over Discord. I'm not gonna be a poker streamer, but I'll share poker stories every now and then. But yeah, 2 games in, I'd already earned the nickname 7-2 Stew, and after like enough like surprising, like a new guy comes in, hasn't seen me before, and I've been really quiet or I haven't played much, so they're cautious around me. And the first hand they play against me is like 7-2. They're like, "What the fuck? You haven't been playing anything. You finally play a hand and it's 7-2." Uh, There's like a really loud mouth, like a sports cheering guy who just like shut down completely for the rest of the night after I bluffed him with 7-2. Um, and at this point, I've introduced myself to enough people that way that now just everyone knows. And if you're first time meeting me at the table, like someone will tell you, and they'll be like, "Yep, yep, there it is." Mind games are the best part. My favorite kind of board games are like the anything with a defector. Like a resistance, or mafia, werewolf, secret Hitler, that kind of stuff. Those are my favorite kind of board games with the social deception dynamic. Yeah, mafia was fun, and I played that a lot as a teenager. There was one night. This is at math camp. Uh, I I was catching on to something with 3 players, and I don't know what it was I was catching on to, but I needed something concrete, and so I started pointing out, like, kind of as a meme. I was like, "Hey, these 3 players all have wristwatches. I think they're all the mafia," and I made that enough of a meme that other people got on board with it, and it turned out those 3 players were all the 3 mafia members. True. Afterwards, are like, "How the fuck did that work?" But that's one of the fun things about poker is like sometimes like things at a subconscious level before you know why it works at like a reasoning level. And I like leaning into that intuition. Like sometimes you just know that someone's getting ready to like shove bluff and you can induce them. Sometimes you can solo play them, or sometimes you can just make them fold. Um, and that feeling is like super satisfying when like you kind of just know what someone's gonna do. But it is late, and I need to find someone to raid. So let's do that. Browser. I think Midnight Simon probably went to bed, but if you're still here, I appreciate the raid. It's good to have you back. Okay, Who do we have here? Not a lot that I know. I wish I knew more streamers. Let's just look at the category. Soft, mm, softline game development right here. Um, Universal Chat Client, maybe. I don't know RW Grimm. We haven't seen Sergeant Pepper in a while. Let's see what he is up to. We could drop in on CM Griffin. I don't think I've ever graded CM Griffin, actually. Xkeeper was fun. I don't think Xkeeper is up yet. But that was a fun stream. But the problem with rating fun streamers is then I like stay up too late afterwards, like watching their stream. And it's already late at night. I think I need to move to an earlier time slot. AI building app suggested in chat. It's kind of a funny idea. I'll take a peek at that. Okay, let's do a vibe check, see how people are doing.
And then try to use that. Because that's the other problem we run into here is people don't necessarily want to use and can't necessarily use these.
If anyone has favorites, oh, why am I here?
They're not all Godot classes.
We're gonna look at taking a nap. I don't want to be the one to test this out, but maybe it's a fun idea.
Here, after this.
The thing about Sergeant Pepper's, I can never tell what it is he's working on from like the description. Okay, let's check out CM Griffin.
However, because of the way they were importing CSS files, right? Because of the way they were importing CSS files into these components,
I like CM Griffin well enough, and we've never rated him, so let's do that.
None of the CSS was scoped the way that Vue would do so, and you would actually get like really weird rendering like CSS artifacts based upon what navigation path.
Well, thanks everyone for stopping by. It's good to see y'all. Thanks for being an audience to my poker stories. And yeah, 11 p.m. next week, same time. Great, I'm glad you liked them. There's always more. I play poker at least once a week. Okay.
Level.